Good morning class, this is Rahul Ranjan Sharma, okay. The physics faculty of One Ocean Academy. Today we will read electric circuit connection, electric circuit connection. This is the class 10 topic. Okay. Now we will start the circuit connection. So there be the two types of the circuit connection. First is what? Series connection, and another is what? Parallel connection. Parallel connection. In the case of class 10th, we will read the connection with respect to the resistor. Okay. So now when we talk about the first connection is what? Series connection. So when two or more resistor is connected in a same line, that is end of the one wire is the starting of the other, starting of the other. This type of connection is known as what? Series connection. Okay. So let us see what type of connection and what is saying here. So what it said, if one resistor is connected in same line with another resistor. So this is the starting point of resistor R1, let us say this is A, and this is the end point of the resistor R1, let us say B. The another resistor is what? Another resistor, when we want to connect, it becomes what? The end point of the first resistor become the starting point of the second resistor. So second resistor starting point is from here, okay. That is the R2. Now this is the point C, this is the end point. Now you can connect the end times of the resistor. So this type of connection is known as the what? Series connection, or according to the book style, this become what? All these connection is series connection. Let us say this is R1, this is R2, this is R3. Okay. So this type of connection is series connection. Now, so in series connection, why we read about the series connection? So you need to remember that for series connection, current is constant, I is constant whole over the circuit. Whole over the circuit. Current is constant whole over the circuit. So, and the resistor equivalent in the circuit is equal to summation of the given resistor. If the n resistor is given, that R equivalent becomes R1 plus R2 plus R3 dot 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 up to the Rn. Okay. So we can also write that R equivalent is equal to I is equal to 1 to n of R. This is the equivalent resistor of the series connection. Now, if someone has asked you proof that how R equivalent is equal to R1 plus R2 plus R3 dot dot dot. Okay. So we know that I is constant, means I is constant. So I is constant here, then voltage is distributed here. So voltage is distributed here. So for the same connection, For the same connection, Now, this is the negative side of the battery, this is the positive side of the battery, the current flow from the negative to positive side. So, here the flowing current is I from this point, okay, and the direction is that given here. Okay. So, now it moves from the R3, R2, R1 and it remains what? Constant whole over the circuit, but voltage remains changing. So, voltage is changed in series connection. When we talk about the R3, let us say here voltage is V3. When we talk about the R2, let us say here voltage is V2. When we talk about the R1, similarly it becomes what? V1. Now, so according to the summation of the voltage, let us say it is a V. So, V become what? V1 plus V2 plus V3 dot 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 dot, or only 3 function is given. So, let us say V1 plus V2 plus V3. Now, we know that V is equal to what? I into R. This R is what? This R, let us interchange it with R equivalent. So, V is equal to I into R equivalent is equal to V1, that means what? I into I is passing through R1, okay na? So, here I, here I, here I, everywhere I remains constant. So, I into V1, that becomes what? R1 plus V2, that means what? Okay. So, now we will move towards the another theme of the electric circuit connection. So, for series connection, where it is used for connecting the fuse, for connecting the fuse we use what? Series connection. Okay. For connecting the fuse is connected in series, fuse is always connected in series. Now, move towards the parallel connection. Parallel connection. So, resistors are connected parallelly, That means the angle between the two resistors two or more resistor always remains 180 degree. Always remains what? 180 degree. This shows the property of the parallel lines. Okay. So, let us say what type of connection is called the parallel connection. Let us say this is a resistor, this is a resistor, this is a resistor. If all the resistor is connected in this way, this is called the what? Parallel resistor. Let us say this is R1, this is R2, this is R3, parallel connection, or you can also draw it longitudinally. So, this connection is also a what? Parallel connection, or you can draw the same thing on any angle, okay na? It becomes what? Parallel connection. Okay. So, in parallel connection, when we talk about the parallel connection, voltage remains constant. So, when voltage remains constant, the other will be the variable, means change, that is what? Current changes. So, for each and every resistor, here there will be the what? Different current, depending on the value of the resistor provided here. And in the case of the series connection, for each and every type of the resistor, current will be the constant, but voltage will be the what? Different for each resistor. Okay. So, now voltage remains constant. So, if we connect the given figure by a voltage V, current will be the distributed, here voltage V So, voltage remains here constant V all over the circuit, but current will be the distributed. Current will be distributed. That means what? If I current is flowing through the circuit, flowing through the main wire, then it will be distributed according to the given resistor. So, here it become I1, here it become I2, here it become what? I3. Okay? And now, here on the after the junction, it becomes what? I. That is clear? So, here I is equal to what? I1 plus I2 plus I3. I3. Now, let us say one thing here left, that is the 1 R equivalent. The formula for finding the equivalent resistor in the parallel connection is equal to 1 R equivalent is equal to 1 plus R1, 1 plus R2, 1 plus R3 dot 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 up to the end. So, now according to the given connection, I become what? I1 plus I2 plus I3. Now, we know that I is what? V upon R. Let us say this R is what? R equivalent. So, it become what? V upon R equivalent. Now, on putting the value in the given equation, it become V upon R equivalent. V upon R equivalent is equal to V upon R1 plus V upon R2 plus V upon R3. Now, taking the V common from each and every side, it becomes what? 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now, cancel out the V from here to here, you will get, here remains nothing but 1. So, 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So, the equivalent resistance in the parallel connection is equal to the summation of the reciprocal value of the given resistance. Okay. So, 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. If you wanted to increase it dot 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 dot, and it become what? 1 upon Rn. That is the. Now, let us make it simple for only for the two resistor. So, it become what? 1 upon R equivalent is equal to what? 1 upon R1 plus 1 upon R2. Now, taking the LCM of the given factor, R1 into R2 and R1 plus R2 is equal to what? 1 upon R equivalent. Now, sorry. So, after reversing it, it becomes what? R equivalent is equal to R1 R2 upon R1 plus R2. Okay? So, that is proved. So, R equivalent of the parallel resistor is what? This can be this. R equivalent is equal to R1 into R2 upon R1 plus R2, or this can be this, that is 1 R equivalent, 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 dot 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 up to the n. Okay. Where n is the what? Number of the resistor connected here. Okay. Now, so use of parallel connection. So, home appliances, home circuit is connected parallelly. Why? Because each and every appliances of the home, okay na, note of the what? Bollywood, note of the Hollywood, okay. Here what? Appliances of the home, such like that, TV, mixie, grinder, fridge, whatever, okay na. So, because each and every appliances are made for a given current range, given voltage range. So, if the voltage fluctuate and increase abruptly, if the voltage fluctuate and increase abruptly, this made what? This made burnt the or destroyed the appliances. Okay. So, for saving from such type of the destruction, here it is recommended to connect the wire and connect the appliances in parallel way. That is clear. Okay. So, home appliances or home circuit is connected parallelly. Now, let us see a given question of class 10, that here okay, 5 ohm, 10 ohm, 20 ohm, and this is connected with the another resistor of 40 ohm. You need to find the equivalent resistance in the given circuit. So, first open the wire from any point. Let us say it is opening from here. So, this become what? If we wanted to open the wire from here, this become what? This become this connection moves from here and it becomes such like that 40 ohm. That means what? If we wanted to see this thing, this is what? This is in parallel. And this parallel and this become what? Series. So, first we wanted to calculate the R equivalent, or we need to calculate the R equivalent of the parallel connection. So, for parallel connection, let us say this is a section A and let us say this is a section B. So, for section A, for section A. Okay. 1 upon R equivalent is equal to 1 upon 5 plus 1 upon 10 plus 1 upon 20. On solving the given equation, it become 1 upon R equivalent is equal to 20, 10, 100, 20 plus 10 plus 5, that will equal to 35 upon 100. It means that 1 upon R equivalent is equal to 35 upon 100. Now, after doing cross multiplication, we will get R equivalent is equal to 100 upon 35. That means what? 5 7 ja, 5 20 ja, 20 upon 7 ohm for the connection first. Now, so it becomes what? 100 upon 25 for connection first. Now, so the equivalent resistor, let us say this is the what? 20 upon 7 ohm resistor, and this is a resistor of what? 40 ohm. Okay. Now, this becomes the two resistor in series connection. Okay. Now, so then R equivalent for such type of resistor, this is a series connection. So, R equivalent is what? R1, R2, R3, or let us say R0, it is R0. Okay, na? So, R0 plus RB, this is RB. Okay. So, R0 plus RB, that is equal to what? 20 upon 7 plus 40. That becomes what? 20 plus by 7 plus 40, that means plus 47 ja 280. That means what? 300 upon 7 ohm. So, the equivalent resistance in the given circuit is what? R equivalent is equal to what? 300 upon 7 ohm, and that will equal to on changing the point formation 7 4 ja 28, 7 2 ja 40, 7 8 ja 60, and 7 6 ja 7 5 ja 32. So, that is approx 42.85 ohm. Okay. So, this is the calculation. Okay, na? Now, we will read more in the next video. Thank you. Okay. For any doubt, any type of the clarification, just text me on the given number 93047032214. Okay. Thank you, class. Okay.